Hello everyone, and welcome back to another GIS mathematics tutorial video. And in this video, I want to talk about graphing ellipses given an equation. And this will teach us a couple of different concepts. It will teach us how to take an equation and pull out things like foci, vertices, and covertices. And it'll also teach us how to take those, especially the covertices and vertices, and turn that into a graph. So first of all, what I need to do is I need to actually set up a axes here. I'm going to use red because those are kind of thick lines here. So this is going to be our axes X and our axis Y. And so what I want to do is I want to talk sort of through conceptually deconstructing this equation here and figuring out what it's telling us and what we can get from it to be able to graph the ellipse. So the first thing that we need to know here is that because there is the only things on the top are X and Y, we know that our ellipse is centered at the origin, which means we don't have to worry about any offsets or any of that kind of stuff. Okay, so thing number one, we know that our ellipse is centered at the origin. So I'm going to make a big black dot. That's the center of the center of our ellipse. It's also the origin of our coordinate system. So we know that. Next thing, we know that the larger of the two numbers is always A. So we know that A, ooh, that is really wide. So we know that A is 25, and we know that A squared is 25, and we know that B squared is 4. And if you're confused as to how I got that, just remember that it's X squared over A squared plus Y squared over B squared. So I know that A squared is 25 and that B squared is 4. So this is the same as saying that A is going to be equal to 5, which is just the square root of 25, and that B is going to be equal to 2 because 2 is the square root of 4. Hopefully I didn't lose anyone there. Right. So now we know A, and we also know that, right, that A is the distance between the center and the vertex, either X or Y, depending on which number it's under, or which variable it's under. So in this case, because A squared is under X, this is going to be a horizontal ellipse, which means it's going to be wider than it is long. And so what this means is that our vertexes, have the 5, 0 and negative 5, 0. And if I've lost anybody going from this step to this step, I encourage you to go back and watch the videos where we outlined the standard equations and we talked about how A's, B's, and C's relate to vertices, covertices, and foci. And that should clarify how I got from here to here. Because vertices have A, 0 and negative A, 0 if A is under X, or they would have 0, A, 0, negative A if A were under Y. But because A is under X, we end up with 5, 0 and negative 5, 0. So we can go ahead and we can graph our vertices. So 1, 2, 3, 4, 5. That's our first vertex. And 1, 2, 3, 5. And that is our second vertex. Okay. So then we have B, and we will remember from previous videos that our B here, this is the distance between center and covertex. All right, and so because again we're centered at the origin, this means that our covertex, which is going to be in the y direction, are going to have a value of 0, 2 and 0, -2. Again, if you're confused how I made that leap, go back and rewatch the videos where we laid out these relationships. But what we can do now is we can put the co-vertices on here. So we go 0 and then we go up 2. And we go 0 and then we go down 2. And then let's go ahead and make our ellipse in, how about a nice bright blue? How about orange? Let's do orange. All right, so then now to graph it, all we have to do is basically connect an arc. And I'm not going to, this isn't going to be perfect. I wouldn't expect yours to be either. But we're going to connect the vertices together in an arc that goes through the co-vertices, like that. And this would be the ellipse with this equation. Hopefully that made sense. If any of the parts are confusing to you, I encourage you to pause the video, go back, and rewatch the parts you're confused about. And as always, please reach out. Thank you.